Are you a world builder, game master or author? Do you want to have an interactive, highly detailed map of your world? This tutorial will show you everything that you need to know. My name's Tom, and I'm the author of several online and tabletop role-playing games. For my latest creation, DragonEye, I wanted a highly detailed, interactive world map and atlas. So I developed the techniques that I am showing in this tutorial. You can see them in action at notveryprofessional.com/dragoneye/atlas or click the link right here. What we will be doing is using Asga's excellent fantasy map generator to create a world map, then import that into a professional geographic information system, or GIS for short, software where we can refine and manage it. Then we will use a combination of Mapbox and Semantic MediaWiki to build an interactive online atlas of our world. The result is something like a mix of fantasy Wikipedia and fantasy Google Maps. We begin in Asga's fantasy map generator, and the first thing we want is to play around here until we have the map that we want. For this tutorial, I will just take the first map that showed up here, but what we want to do is we want to make sure that it is placed correctly on the world. This is important because we are going to export everything to a geographic information system, and it needs to be in the correct place in our world at the correct size. So you see, at this size, our map would be a huge continent. If we don't want that, we will reduce the size a little bit and we can move it to the north or to the south. We should not move it too close to either pole, or there will be a lot of distortion in the map. This is a nice continent just south of the equator, most of it. We will leave it at that. The next thing we want to do is we want to export all this data. The first step is always to save the actual map, because this can be reloaded into Asga's generator. And if you want to change anything, update something, or you just forgot something, you need to export again, you will need this map file. So always make sure you save this map file. The next step is that we go to the JSON export, and we want to export all of these elements, so the cells, the routes, the rivers takes a small moment always, and we also want to export these markers. This gives us all the geographic information in GeoJSON format. But we are not done with that. We also want to export information about our cities in CSV format. This will give us the province and state and culture and population details and all of this. So we click this button here and it will export a CSV file. We do the same for the rivers. And then we have the basic data for these. We also want to export the data on biomes and on states, and on provinces, basically all of it. You can leave the diplomacy data, always leave the diplomacy data out, but you can export that as well if you want. And let's not forget the religions. You can also export the zones if you use them. So now we have all our data in various types of text files, and now we will switch to our geographic information system. There is actually an instruction on how to use the GIS data export on Asga's GitHub page. You can follow these steps, which include some links and some how to, but I will explain everything in more detail here. For this work, we are using QGIS, which is a free and open source geographic information system tool available for Windows, Mac, Linux, and BSD. You can download it at qgis.org, and I've already started a new project here. We will now be importing all of our ASCA map data into QGIS. One more step that we do outside of QGIS before the next one, but I am going to import our cell data to show you why we do it. So to import data into QGIS, what we are doing is we use layer, add vector layer, and then we will just select from whatever directory we saved all our map data to the file with the cells data, open it, add it to the map, and voila, there you see all the basic map structure of the map that ASCA's generator has created. It doesn't look anything like the map that you saw in the generator itself, but hang on, we will get there. There is one small problem with this map, however, and that is visible if you zoom in. You see that all the lines are very straight. You see the artificial Voronoi cell structure that is underlying the map generator. We want to have this look a little bit more organic, at least a little bit more natural. So there is a small script that I've written that we will be using now. So the add random point script, which you can also find on my website that I've linked in the description of this video, is just a very simple PHP script that goes through the geometry and just adds some randomness to the point. It adds some additional points in between the polygon points, and it just makes for a more natural look. That's all. It does need some memory depending on how large your map is. I've set PHP's memory limit to 512 megabytes on this computer, and it was enough for all the maps so far. But if the script fails with an out of memory error, just raise the memory limit for PHP. We will run this script on the map data that we created, which is in the cells file, and we will just redirect the output and save it in a new GeoJSON file like this. It takes only a few seconds. There we go. And then we can import this layer, add vector layer, pick the new file that we created, add it to the map. And you can see the difference in the lines here. They became such a little bit more organic and more natural. Deleted the old layer because we don't need it anymore. We now need to do some cleanup work because unfortunately the GeoJSON import will leave us with a few topological errors. It's not very difficult to do. What we need to do is go to Vector, Geometry Tools, check validity. And since we're not interested in the valid cells, we uncheck this and create only the other output. It runs for a few seconds and it will tell us all the places where there is a problem with the geometry. There are 9 errors in our file and we will simply go and fix them by hand. This will be easier if we set this layer to be transparent, because then we can see the underlying layer. And also if we can change the color to something that is actually different from our main layer. Okay, now we can see it. Make sure that you've selected the layer that you actually want to fix, not the layer that just shows the problems. And you can see at these dots where the problem actually is. So we toggle editing and enable the Vertex Tool. And now we can see here what the problem is. Very clearly, there is a line going from this point to this point, which is actually outside the polygon. So we need to select this point and simply delete it. Now the problem should be gone. Save. And we can still see the problem in the invalid output layer because it's not updated, but the problem should be gone. The other type of problem, which I suspect we will see here, is when the randomizer juggles the points to the wrong side of a thin line. So again, we go to the Vertex Tool. Now we need to fix these two, which are just the wrong way around. But we want to make sure that we fix all the adjacent cells as well. And there is a very good function in QGIS, which is this enable topological editing. To see this toolbar, you may have to right click and enable the snapping toolbar here. This contains the enable topological editing. So what we will do is we will just select these problematic vertices, which is this one, and just drag it somewhere where it doesn't make a problem, and this one, and the same, we will just drag it somewhere and make this corner look like it could be the corner of some landscape. And our polygon is fixed. Again, this layer which marks the invalid points remains. It's not updated automatically, but if we run the check again, it will have disappeared. And we will now go and simply apply the same fixes everywhere where there is a problem. This strange sound you hear in the background is just my cat, which came to lie on me and purr a little bit. We have our basic cell data, and we'll do one more step that you may or may not do depending on what exactly you want to do with the map. For me, it is more useful to get rid of these ocean cells, which are not useful at all. For this, I will use select feature by value here from the toolbar, and in type, I type ocean and make sure that you set to equal to, and then you can select features by type. So this selects all the ocean types. These fields are all the cell data that was exported from ASCA's generator. Now I can toggle editing, and this button here means delete selected. And with that, all the ocean cells are gone, and I can already see the basic shape of the map as it was in ASCA's. So we will save this data, go out of editing mode, and this is our basic for doing all the other work. If you remove the ocean data like I did, you probably want to do it before you manually fix these cells, because some of these cells I would not have to fix if I delete them anyway. But again, it depends on what exactly you want to do with the map, if the ocean cells are useful for you or not. Go and extract the states, realms, countries, what you want to call them, religion and culture information from the map. And we are using QGIS features to do so. So we will go to Vector, Geoprocessing Tools, Dissolve. This allows us to collect all the cells that share. So the first is that we will dissolve by the state field. and this will give us a map that shows all our different realms. So the next thing that we will do is we will put these back into individual polygons, which is done in Vector, Geometry Tools, Multipart to Single Parts. Because at the moment, every state is exactly one polygon, even if it includes islands, for example. And we do this for a reason, because there are two lakes in our map. If we remember the map correctly, and if we don't, we can just go to cells, select features by value, type lake equals, select features, and it shows us that yes, indeed, here are two lakes. We can zoom in a little bit. And if you look at the single parts, you will notice that these two lakes actually are shown like realms, because they have a different state field from the surrounding area, namely 0. They don't belong to any state. But usually on a map, a lake completely enclosed by a country is considered to be part of that country. So we will go to this layer, we will toggle editing, and then we will select this, delete it, select this, delete it, save, and toggle editing. Now these cells are missing. This is not what we actually want. So we will do some more editing step. We will again toggle editing, and now there's a feature here in this advanced digitizing toolbar, which you may have to enable the first time you are using QGIS, and this is delete ring. If we go now and click on this missing part within the polygon, it will actually remove it. So this now is considered to be part of this country. The lake has disappeared. We can save, toggle back, and we have the first version of our realm map. But there is still some work to do, because if we now go here to the attributes table, we will see all our polygons. And the first thing we see is that in the state field, it lists the ID number and not the name. And there's also some information missing, which we will add now. But first we will clean up this by using the toggle editing mode and then the delete field. Because when QGIS collected all the various cells into one polygon, it also merged all these fields, which of course are different for every polygon. So for example, the height, it just took one random field and used it for the height value of the entire country polygon, which is of course wrong. So we will delete all of them except for the state field, which we dissolved by. This gives us a cleaner data set. We will save, edit, exit editing. And now we will add the CSV data that we also exported. We do this by going to layer, add delimited text layer, and then we simply select the states CSV file. Make sure that in the geometry definition you select no geometry, otherwise it won't let you import this file, because there is no geometry data actually in the file. So this add will be gray. Change this to no geometry. Here you see an overview of what it will import. We will add this now to QGIS. It doesn't do anything yet because it doesn't have any geometry, so it can't appear on the map. But if we double click here, there is in the layer properties a function called joins. And here we will add this CSV as a join layer. We will join on the ID. Our target field is the state that we selected, and we can actually select which fields we want to join. We only want the state name and the color. We can actually join the ID field as well if we want it. Maybe it will be useful in the future, who knows. We could also use other fields if we need them, but I don't think we do. We will also set the custom field name prefix to nothing because it's not useful for our purpose. Now we will see here the join settings. We apply it. We export our layer by going to Layer, Save As. We want to save as GeoJSON. Then we make sure that we are saving into the right folder, and we save this as states, GeoJSON. We don't want to export the state field actually, because this and this is always the same, because this is what we joined on. So check if there's everything that you want, and if we leave this check mark here, it means it will be added to our QGIS project automatically. This is what we want. Click OK. And there we go. We can now delete all these temporary layers that we don't need anymore. And we can color this more beautifully by double clicking and then going to Symbology. There are many different options in QGIS to color, but we do have the color data from Ask Us Generator. So we simply select the simple fill and we go by field type color. And we also want to make our borders maybe red, like country borders often are on maps. We want to make it a little bit more thick. Okay, apply, and here you can see our realm map. We can also add labels, for example, by going to labels, single label, pick the state name, set some nice font, maybe place it in different mode. QGIS has many options here. If you want to do this or not depends mostly on what you want to do with the map, how you want to use it further. Since I will be using Mapbox to show the map on a website, all the styling here will have to be redone in Mapbox anyway, so I'm not putting much effort into this styling in QGIS, just to show you that there are many things that you can do here. If you want to use everything in QGIS directly, then you can make it more beautiful. If you want to export from QGIS, you can change it into an overlay or whatever serves your needs. My main purpose is for editing and fixing and adding more details to the map in QGIS. So you will notice that most of the coloring and so on that I do is purely functional so that I can work with it. It's not made for beauty. That will all be done in Mapbox later on. For cultures and religions, we simply repeat the same steps. So we go to cell details, draw processing tools, dissolve, and then we dissolve based on the culture, for example. Then again, we turn everything into single parts. Then again, we will add the culture's CSV file, no geometry. We will clean up our data set, leave only what we've merged on. Then we will join it. So with the cultures, we'll join on ID, culture. We will join the ID, the culture name, and the color. We will remove the prefix. Then we will go and remove these lakes. we will close this ring. I will leave this ring in because it actually touches two different cultures. It is not completely enclosed, so it could be considered misleading on the map to actually include this in one of the cultures. So we will not do that. We will just leave this open. There is no culture on this lake because nobody lives there. So now, again, we have our basic data, which means we can save this again as our cultures map. Again, don't export the string anyway, it's duplicate, add it to the map. There we go. Remove the temporary layers and here we go. Culture it by the same color. Here we leave the borders as they are. They are not political borders anyway. Here we go. Maybe add label for the cultures as well. Something like this. Or no, there are these buffers to make it stand out a little bit. Experiment or follow some tutorials on QGIS if you want to use this extensively. I'm mainly doing this here so that if I enable more than one layer, I can clearly see which names refer to states and which refer to countries. So there we have our states and our cultures. We can see where they overlap and where they are not. You see here is some minority, for example. All this is information that we can later use in our world building to create interesting stories about specific regions on the map. And for religions, we simply repeat the exact procedure once more. Now it is time to do something more interesting. We will keep these layers but disable them for now. We will use the same basic approach on our cells again, but this time we will dissolve by biome. This is the information about forest, grassland, and so on that we have created. And now we see here our biomes. And if you remember, we exported as well a text layer for the biomes because we have the exact same problem here as we have with all the other data. The name, for example, is not included in the JSON output. So add this, close it, again, clean up the attributes table here. This time we want to keep the biome, save, and join on biome. And we can include whatever fields we think might be useful to us. And again, when we are done with all of it, we can save our layer. And again, resolve or remove these parts. And again, here we have the color information. This we will actually set to no pen so that there is no black line around the biomes. They will simply flow into each other more or less naturally. And now we have a map that looks a little bit similar to the map that the ASCII generator created. We have our overlays here, and we have our basic map data, which we can use to work now on details. Now we will add rivers to the map. We exported the rivers as well as a JSON file, if you remember, but we will have to do one small manual editing step. We'll need to open this in the text editor of your choice, because the ID in the JSON file has this prefix. It is called river1. And if we want to merge this with the CSV file, there is as an ID only the number. So we need to remove this prefix, which is easily done with just in any text editor, just search and replace. Remove this so that the river part gets removed. Any way you want to get rid of this. And then, as before with the cells layer, we will add this as a vector layer, and we will pick the rivers GeoJSON file in this place, add this, and here are the rivers. We can make them blue by changing the symbology. QGIS is some prefixes. We'll pick this one. Here we can see our rivers, and again we will add the text layer with the additional information such as the names. Here we see the names, the type. This is a small map. It has only one river, which is not of type river, but in a larger map there will be many more different types. So we add this, and then as before we use join to combine these two files. We join on the same field here on ID. This will work because one is in a capital and one is a lowercase letter. We'll join them all, remove the prefix, and then we should have one layer, and in the attribute table we will see the river name for everything. And we will save this layer as a GeoJSON file with the information that we want. I will just leave this in here. It's not a big deal. So here we go. Remove the temporary layers that we don't need anymore. And here we are again. If you load a new layer, it will forget about the symbology. You can just set it again. For me, it's not important because I just work in QGIS for the settings. One thing about the layers is that unfortunately they don't always fit exactly. So you should go in and see if you find places like this where a river doesn't actually meet another river exactly. You can simply turn on editing, enable the Vertex tool, and then you can just add some vertices. And if you have snapping enabled, it's really easy to make sure that they meet, and to make a nice bit of a curve there. And if you are worried, depending on what you want to do with the data, you will see that rivers are very exported in much detail. So there are many points on these lines. If you don't like that, you can use vector geometry tools, simplify, and here you should add a low value, something like 0.003 maybe. Depends on the size of your map a little bit, and you will see that you get a simplified version of the river with much less points in between. The final piece of data that is just pure export-import functionality is the towns and cities, which in ASCII are called burgs. So we will import this as a layer. However, we need to import this as a delimited text layer because they are exported not in GeoJSON, but in CSV format. Unlike the other information, however, they do have longitude and latitude fields. And QGIS should be smart enough to pick these automatically simply by the names. Make sure you have point coordinates selected. And if you want, you can also set the Z field, which is the elevation, which is also stored here. But it's not used in maps unless you go 3D. So just click on add and voila, there you have all your towns and cities added to the map in their proper location, and you can work with this as with any other field. For example, we can add the name of our burg everywhere so that you can see where your places are. I anyway recommend to export this as a GeoJSON file. Let's call it towns. And the reason for that is very simple actually. If you want to change anything, for example, here we have this lake, and I want to move this town which is placed inside the lake, maybe because of the random changes in this line, or maybe because of a small error in the point coordinate calculation. If I want to move this town around in the CSV file, I actually can't. QGIS cannot edit CSV files, so I cannot turn on editing mode and I can't change the position, name, or any other information here. But if I saved it as a GeoJSON file, then I can very easily just fix the position of this town, save, done, and this way I can fix any problems that I might spot, or I can just move my towns around if I want this one a little bit closer to the coast, or if I want to move something away from a river. Whatever I want to do is very easy if I've saved it in a GeoJSON file. That's why I recommend that you do that. The last data from the ASCA generator that we want to add to our map is the roads and trails, which were also saved in a GeoJSON file. We add this, and this is the most easy of them all. It's not visible very much. We can just change it to something more visible, maybe like this road. There you go. And this has no CSV file with additional data. There are no names generated for roads or some such. So we are actually done. This is all we need to do. We don't even have to export it because we didn't change anything. Again, we can go in QGIS, we can add details, we can change roads, delete roads, add additional roads, whatever we want to do, we can do here. But now we have everything that was exported from ASCA in our map. Actually, there are zones exported as well, but I'm not using them. So that's something I didn't show. And there is province data as well that basically works the same as religions and cultures. So I will not show this as well. It's absolutely the same. They have names, they belong to some country, and they have a CSV and a CSV file that you combine with the cells details. That's all. So here we have our road map, our rivers map, our towns, our biomes, and we have our overlays for countries, religions, cultures, whatever we want. And this is the basic steps of getting your ASCA map into QGIS. And from here on, we'll proceed with more advanced editing, more advanced processing of this information. And then we will see how we can export all of this to show it on the internet. And that concludes the first part of the tutorial. I've shown you how to create the map in ASCA, export it and import it into QGIS so that we can continue working with it. In the second part of the tutorial, I will show how to import all this data into Mapbox and use it on the internet. If you want to be one of the first to see the new tutorials and get more detailed information, or if you want to support me in my effort to create the Dragon Eye world, go to my Patreon page and subscribe there.